Hello everyone and welcome to another exciting tutorial on graphs of functions. Now in today's class we'll be discussing graphs of quadratic functions. As we know, quadratic equations or quadratic functions are those second degree polynomial in which the highest power of the variable is 2. So now the forms of quadratic equation. There are three general forms of quadratic equation. Either a quadratic equation can be written in this form, where y is equals to ax square plus bx plus c, and this is the most common form that you have been coming across so far. Now, when you factorize those quadratic equation which can be factorized can also be written in this form. Okay, so y is equals to x minus h times x minus k, or y is equals to minus x minus h times x minus k. This is another general form of writing a quadratic equation. So and the third form, this is the factorization form, and this is the completing square form. In a completing square form, what you as you can observe over here is that the general equation can be written as y is equals to x minus p the whole thing square plus q, or y is equals to minus x minus p the whole thing square plus q, where p and q are the coordinates of the turning point. Okay, now the graphs of a quadratic function is a parabola. This shape is known as parabola. Now, how do you decide if you get a minimum curve or a maximum curve? Is by looking at the coefficient of x square. If the coefficient of x square is positive, meaning this a is positive, then you will get a minimum curve. If this a is negative, you will get a maximum curve. A minimum curve is a curve which has a minimum point as a turning point. A maximum curve has a maximum point as a turning point. Now, if you consider this factorization form, if you have positive value over here, in our case it's positive 1, then you will always get a minimum curve. And if there is a negative value over here, which means that when you multiply, the coefficient of x square would be negative, hence you get a maximum curve. Similarly, while looking at completing square form, if the value over outside the bracket is a positive value, in our case it is positive 1, so you get a minimum curve, and if it is negative, you get a maximum curve. So the bottom line is that if the coefficient of x square is positive, which means it's greater than 0, your parabola or the quadratic curve would be a minimum curve. If it is negative, then it will be a maximum curve. Moving on, the things that you must know while sketching a quadratic graph are the x-intercepts, the y-intercept, the turning point, and the general shape, whether it will be a minimum curve or a maximum curve. The x-intercept is a point on the x-axis where your graph would be intersecting the x-axis. The y-intercept is a point on the y-axis. And now the line of symmetry. The line of symmetry is a point which divides the curve or the quadratic graphs into two equal halves. So this is the line of symmetry which must pass through a minimum point. This is the line of symmetry over here which must pass through the maximum point. The line of symmetry would divide the entire graph into two equal halves. So now let's look at the general form of a quadratic equation and look at how the graph varies when you change the values of coefficient of x squared, that is a, the coefficient of x, that is b, and the value of c. So let's look at what does changing these values would do to the graph. So let's say if a is positive, alright, and you keep on increasing a, what happens is the slope becomes steeper, the curve is more steeper than as you increase the value of a. This is you are getting a minimum curve because the value of a is positive. Now if a was negative, the curve is a maximum curve, as we discussed in the previous slide. Now this is what happens when you change the value of b. and when you change the value of c, it is only responsible for vertical movement. So for example, if you have the equation 3x square plus 4x plus 6, so if you closely observe, you will get a y-intercept at 6, and this graph lies above the x-axis. Now there, changing the equation will somehow change the roots as well. So now there are roots present where your graph is cutting the x-axis. Okay, so now let's look at the graph of the form y equals to x minus h times x minus k. Now these are the factorized form. Now if you have a quadratic equation that is represented in this form and you are being asked to sketch the graph, for example in this question you are being asked to sketch the graph of this equation, this function, you need to realize that it's a quadratic function. The way you will proceed for this question is, first of all you need to identify whether it will be a minimum curve or a maximum curve. Now in this example it will be a minimum curve because it's the coefficient of here is a positive value, so we know that it's a minimum curve, and minimum curve has a general shape like this where you have a minimum point. The next thing that you need to understand is how to find the x-intercepts. So in order to find the x-intercept, you will use the equation and you will plug y as 0 and find the two values of x. Since you are getting the two values of x, it means that the graph is intersecting the x-axis at x equals to 1 and x equals to 5. These are your roots. In order to find the y-intercept, you will place x as 0 and you get 5. Now you have the x-intercept and the y-intercept. Let's have a look how the sketch should have been look like. We have coordinates, we have the x-intercepts at 1 and 5, the y-intercept is 5, and it's a minimum curve, so obviously the parabola should look something like this. Okay, now in order to find the turning point, what you can realize is this was 1, this was 5. The turning point or the minimum point will be lying on the line of symmetry, so it will be equally, the x coordinate would be this, and it will be equally apart from this point and this point. So in order to find the x coordinate of the turning point, you can take the average of the two intercepts. So x coordinate of turning point could be found by taking the average of the two values, and then in order to find the y coordinate of turning point, you can use the same equation again and plug x as 3. So you get minus 4. So this value comes out to be minus 4 and this value was 3. So the minimum point is 3 comma minus 4. This is your quadratic sketch for this function. Now how do you think the graph would have been different if we have the equation y is equals to minus x minus 1 x minus 5? Now the only difference is of minus sign, so now this means that it's a maximum curve which has a shape like this. It's a sad face curve also. The x-intercept would remain same, but for your understanding, as for the first question, what you can solve it. So in order to find the x-intercept, you would have taken y as 0, and what you will notice from here is that the x-intercept comes out to be same as the previous thing. For the y-intercept, you will take x as 0, and from here you will observe that the y-intercepts comes out to be positive 5. That's the difference. Now the time comes for the x coordinate of the turning point. In order to find the x coordinate of the turning point, you will take the average of the two roots, two x-intercepts, because it will be lying on the line of symmetry. So again it comes at 3, but the y coordinate this time would change. The y coordinate of the turning point would be, you will plug x value back into the equation, and what you observe from here is that the y coordinate comes out to be positive 4. Now if you sketch this graph, the x-intercepts remain same. The y-intercept is the y-intercept is negative 5. Guys, I just made a small mistake over here, please correct it. The y-intercept is negative 5, and since it's a maximum curve, it will look something like this, and the turning point are 3, 4. So it's a maximum curve with turning point 3, 4. By the way, the questions also ask sometime for the equation of line of symmetry. Since we know that the line of symmetry will always pass through x from the turning point, the equation of line of symmetry is x equals to 3. So in order to summarize, what we have done over here is that for the equation that is positive, that is in the form of positive x minus h times x minus k form, the graph actually opens upward. It's a minimum curve. The graph cuts the x-axis at this point h and this point k. The graph is symmetrical about the vertical line that passes through the minimum point. Now for the equation y equals to minus x minus 1 times x minus 5, which was in the form of y minus x minus h times x minus k, the graph opens downward. The graph cuts the x-axis at h comma 0, which means that in this example 1 comma 0 and 5 comma 0. The graph is again symmetrical about the line passing through the maximum point. So the equation of the line of symmetry, as we discussed, is x equals to 3. Okay, so the other form of a quadratic equation is the completing square form. So these are the example. This is the general form of a completing square form, where your p and q are the coordinates of the turning point. So for example, you have a quadratic function that is written in this form, which is a completing square form, and this equation represents a curve. Now the thing to notice over here is that since it's the outside bracket, there is a positive sign, which you can also say a positive value. So the graph of this function will always be a smiling face curve or a minimum curve. It will open upward, and the coordinates of the turning point can be directly picked from here, which are 1 comma 2. Now if the equation would have been y equals to x plus 1 the whole thing square plus 2, then the coordinates of the turning point would have been the x coordinate would have been minus 1 comma 2. The example for this equation would be y equals to minus x minus 3 the whole thing square plus 5. Now in this, the coordinate of the turning point would be 3 comma 5, and because of this sign it will be a maximum curve. So you might be asked to sketch y is equal to x plus 1 the whole thing square plus 2. So the way you are going to sketch this graph would be, by looking at the equation, you know that since this is positive it will be a minimum curve. Then go for the turning point. The turning point would be minus 1 comma 2. So minus 1 comma 2 would be somewhere here, and since it's a minimum curve, the graph open upwards. There won't be any x-intercept. Okay, so this is minus 1 and this value is 2. Let's take another example. Let's say if the question says sketch y is equals to negative x minus 1 the whole thing square plus 5. Now by looking at the negative sign over here, you can decide that it's a maximum curve, and the turning points are 1 comma 5. So 1 comma 5 somewhere here, and then since it's a maximum curve, it will open downwards and will have some x-intercepts and y-intercepts, which can be found, as we have learned in the previous slide, that x-intercepts can be found by plugging y as 0 in your equation, and y-intercepts can be found by plugging x as 0 in your equation, because on the y-axis x is 0 and on the x-axis y coordinate are 0. So let's look at some another example. Alright, so the question in front of you is to express x square minus 4x plus 2 in the form of x minus b the whole thing square plus q. So this form was the first form, that is ax square plus bx plus c. You are being asked to express this form into the completing square form, and the way you are going to go about this part is this: x square minus 4x plus 2. Now in order to apply completing square form, or convert this form into completing square form, the first step is to make sure that the coefficient of x square is positive 1, which in our case is. Then what you do is you write the first two terms, you take the coefficient of x, you half it, you square it, and you add it. Now this is something you have done on your own, so in order to have no effect, you will subtract it as well. Now why are we doing this? Because we have to make sure that the first three terms are coming in the completing square form, plus 2. Now if you see the first three terms, they are the expansions of a minus b the whole thing square, where your first term is x and the second term would be 4 over 2. Now so you can write this as x minus 2 the whole thing square, and you can resolve the rest of the things further. So this would be minus 4 plus 2, which is minus 2. Hence you have your completing square form. Okay, now for part 2, the part 2 says write down the coordinates of the minimum point. Why are they referring to this as a minimum point? Because the coefficient of outside the bracket is a positive number, so you will have a minimum curve, hence the turning point will be a minimum point. And in order to write down the coordinates of the minimum point, you can look at this over here. You can pick the values from here. The turning point, the minimum point coordinates are 2 comma minus 2. Remember, there is x minus 2, which means the x coordinate would be 2. Then you are being asked to sketch the curve. Now sketching this curve is same as sketching this curve, okay, because it's the same equation, just a different way to write it. The advantage of sketching from the competing square form is that you already know the turning points. So it's a minimum curve and the minimum point are 2 comma minus 2. So let's say roughly 2 comma minus 2 would be here, and this is how the graph would be. Let me draw it again. Okay, this is 2 and this point here would be minus 2, so the turning point coordinates are 2 comma minus 2. The y-intercept can be found by plugging x as 0 in the equation. So if you place x as 0 in the equation, or you can directly see from here as well, the x coordinate, the y-intercept is 2. Okay, so that's your equation, y equals to x square minus 4x plus 2 graph. In the next part, they are saying state the equation of the line of symmetry. So the line of symmetry is a vertical line that passes through the minimum point or the turning point in this case. So this vertical line that is parallel to the y-axis will have the line of symmetry. The equation would be x equals to 2. Thank you guys for watching this video. I hope this lecture on quadratic graphs is clear to you.